Hello everyone, I'm Suman Radhige from the University of Wollongong. Today I'm going to present on the topic effect of mixing the tire chips on the thickness of the subbase material. As we know that the scrap using of the scrap tire, it increases the strength of the soil or any of the subbase. So like I'm going to present what does it affect on the thickness of the subbase on this presentation as a part of my assignment of ENGG955 engineering research method. In this research, I'll be including my introduction about my topic, and then the literature review, how I come to the design of how I come to the topic, and another one is the research design, what I'm going to do as to check the thickness of the subbase, and other one is I'll be concluding all my presentation at last. If you see that around 1.5 billion scrap tires are produced all around the world every year, and if we see in Australia is like around 25 million scrap tires are produced every year. If we see the numbers, it's very devastating. So it creates a serious problem to the environment. As we know that the tires, if we burn it causes the air pollution, and if we just if you just store in the land, then it will cause the land pollution, or it is non-biodegradable. So so the latest researches has been made on the use of the scrap tire to be used as a geomaterial to increase the strength properties of the soil and the gravel subbase and all. And it has been extensively used in the field of the construction of the roads and railways these days, as it can increase the shear strength properties of the subgrade and the subbase. Going to the history of the research, it has been found that the shear strength of the clay and the peat swell has been increased by the use of the tire chips. Other thing is though, as the tire is the comparatively lightweight as compared to the other material, it will decrease the weight of the backfill material, so it can be easily used for the backfill in the retaining walls, and also in anywhere for the backfill purposes. And other thing is it can increases the permeability of the other researches has shown that the permeability of the soil has been increased by the use of the scrap tires. If we use beyond the 10%, if we mix the tire thread like among like 10% of the 10% of the mixture, then it will increase the permeability of the soil. That leads to that acts as a very good drainage material. Like if even in the backfill of the retaining wall, if we use it, then it can act as a very good drainage material that protects the retaining wall too. And the CVR and the other researches has shown that the CVR of the subgrade soil has been increased up to 21% by using the scrap tire. And it has been found that the optimum content of the tire chips is just 2%. If you mix the 2% of the tire chip on the mixture, then obviously then the CVR of the soil will get increased, and it also it decreases the shear strength properties of the soil, that is the tangent modulus and the shear strength, peak shear strength has been found decrease with the increasing straight tires content. So it is very necessary to optimize the use of the tire, use of the tire thread. And coming up to all these researches so far, I'm now going to research on the use of the tire, how the use of the tire thread affect the thickness of the subbase material, as we know that it increases the CVR and the shear strength properties of the soil, and how it affect on the shear strength and the CVR properties of the subbase material, so that we can decrease the thickness of the CVS of the subbase material. For this design, I'm going to do the experimental experiment design for this, and then for this I take the prototype of the road with the road of the 1 meter length, and this 20 centimeter width, and I take the subgrade material at the 20 centimeter, and then sub base at the 10 centimeter and base at the 10 centimeter, and the 2.5 centimeter of the WBM. And I take the subgrade as the cohesive soil with the CVR of the 5%, as we know that as per our standard the CVR of the subgrade must be 5%. So I just assume that the CVR of the subgrade is 5% here, and then I choose the river gravel as a sub-base material, so that I want to verify the how can we decrease the how can we increase the sericin properties of the river gravel using the trial sheet, and how can we decrease the thickness of the trial sheet so that it will be economical. As we know that if we can decrease the thickness of the sub-base, then obviously it will be more economical. So and we use the base course as a cross aggregate, and at the weighting course we use the WBM, and for the scrap tire we use the locally available scrap tire. And after making the prototype, then we do the various laboratory experiments like the sieve analysis, for the the particle size distribution and everything. We do the sieve analysis for the river gravel separately and the trial sieve separately, and again after mixing we again do the sieve analysis of the mixture after mixing it, and then we do the gradation, and we check the MDT and the OMC of the tile. First separately the river gravel and the tile chips, and again the mixture, and then we do the permeability test, so that we know that if sub-base must be a bit permeable, so that we go for the permeability test, and we test the main is the we go for the CVR test. We take the CVR test for CVR test with the river gravel first, trial thread, and then with the mixture, and then we go for the triaxial test, and we for this all the tests we check with the different proportion of the trial thread, like we check for 1% of the trial thread, 2% of the trial thread, 3% of the trial thread, 5% of the trial thread, 10% of the trial thread, 15% of the trial thread, 20% of the trial thread, and then we go from all the results obtained from this test. From the results obtained from this test, we go for the we verify the results, and then we analyze using the ostrode for the thickness of the sub-base, so that how far we can vary the thickness of the sub-base. And after we verify the thickness of the sub-base, when I will be performing the economic analysis, so that how the use of the trial sheet will be economical in the using for the sub-base. At conclusion, from the different literature, from the different researches made till date, it has been found that the mechanical properties of the sub-base has been increased enough as per this pavement standard, from the Australian standard Australia. And the shear strength, if you see the shear strength properties, cohesion and the angle of friction increases with the addition of the 10% of the tire threads, and beyond which that it has found that to be decreased. Despite the advantages of the tire threads, the excess use of the tire threads, it will increase the permeability, but it decreases the shear strength and the severe value of the swell, which we are not expecting to happen. So the right use and the right proportion of the tire set is important for the economical use of the tire set in the geotechnical part of the construction. So this was for today. Thank you.